Ever go out with your spouse only to have your date night interrupted with constant worries about how the kids are at home? Ever have to stop the music and step outside to call mom to make sure she took her medicine? Tended app founder Ryan Rounkles is working to make sure that when it's time to let the good times roll, your loved ones will be taken care of while you enjoy your dinner. Instead of taking out your phone, you can pass the buffalo wings. A RavenDB user for almost a decade, Ryan develops Tended app to help parents maintain round-the-clock eyes for their children, parents, and even pets. It's a medical services app designed for children with specific needs. It can be something as simple as the sniffles or a 24-hour virus to special needs kids which require constant attention. Tended alerts a caretaker to what actions are needed at any given moment. Whether at work, on errands, or spending the evening out together, parents can breathe easy with the confidence that everything is all right at home. Today, Tended app developer Ryan Rounkles shares with RavenDB CEO Oren Aney how he develops his application and the interesting things he's doing with RavenDB. You will discover how Ryan adapts RavenDB to a mobile environment, syncing data when connectivity is unavailable, improvising a RavenDB document store inside your iPhone, how data subscriptions and document versioning enable a feature-rich app without having to spend time, money, smartphone memory, or complexity on additional resources. Feel free to ask questions by clicking the Q&A button at the bottom of your screen, and Ryan and Oren will be happy to answer them throughout the session. Enjoy your presentation, and here's Oren and Ryan.
Hello, Ryan. Thank you for joining me.
Hi, Oren.
So, what is this application? What have you built?
So this is a always-on mobile application whose entire purpose is to let family members feel confident about the care of their loved ones when they want to go out. And so it came about, we had a child that needed medical care when she was younger, and my wife and I could not feel confident leaving her in the hands of a babysitter. Even if they had all of the instructions, we just got nervous. And so we said, hey, what if there was a way that we could go out and still know that our care needs for our loved one were being taken care of? And so this app makes sure that a babysitter or caregiver for your child, your ailing parent, or some people even use it for pets, knows exactly what your loved one needs and has a script of what to do next. And as they perform those actions, giving a medication, taking a blood pressure reading, etc., you get a notification that that was done. And so while you're out on a date night with your wife, you can say, hey, look at that. I just got a notice that said the babysitter gave Jonathan his insulin. Okay, she remembered, she saw it on the app, we can move on. And then it helps relieve that worry while you're out that your loved one is being taken care of. It also helps ensure that you don't accidentally give too much medication. I'm sure anybody who's had a newborn at home can remember, right?
No, this is a painful topic. I have at the time I was 8 months old, and he had a fever. And me and my wife were doing shifts basically, and completely out of it. And yeah, did you give him the cold medicine was dropped a few times. Yep. Not a big deal with cold medicine, but for other stuff, yeah, absolutely required.
Yeah, it's amazing what sleep deprivation can do to your memory of. I distinctly remember giving my child that medicine, but was that 6 hours ago on my previous shift, or was that 10 minutes ago?
I know that feeling.
Yeah, no, it's a terrible feeling. It's terrifying, and this really helps. And honestly, I actually use it for myself. I'm not on any urgent medication needs, but like if I take an Advil because something's hurting, it's nice to have something I can look back at and say, oh, okay, I can't take another one for 2 hours. I guess I didn't take it as long ago as I thought. Mm-hmm. And so that's the why. Let's get to the fun stuff. So one of the critical needs of this app is that it has to always work. And most importantly is if you say you gave your loved one Tylenol or insulin, you really did that. Like that was an action in the real world, and the app is just tracking that occurred. which means that when there's synchronization between different devices or a device and the server, there's no such thing as a sync error or a conflict resolution. There can't be, because you hit that button that says I gave them insulin, that means you really gave them that medication. That was an interesting problem to solve. You know, most developers are used to, hey, if we're going to synchronize data, there might be some things that look like they happen close in time, and we'll just figure out, we'll pick one and it will. Yeah. And I don't think any parent wants to look at a get three-way merge when you're sleep deprived.
I'm a developer and I don't want to do that.
Right, right. I'm always looking for a new tool to do that. And I did not want to do that with this data. So I was like, okay, we have got to make sure the devices are authoritative. And I've been developing mobile since iPhone came out. And the words that I hate to hear more than anything are, you have to trust the device's data. It's a terrifying prospect because you don't know how its connectivity has been. You don't know anything about it. And so it was a complete paradigm shift for me to build an app that says the devices are authoritative on this. Now, that said, they're only authoritative on what happened. I gave a medication or I added a new medication. For example, if you've added Tamiflu because your child came back positive for influenza, that actually happened. You added the Tamiflu to them and you probably gave them a dose. Those are the kinds of things the device owns the data for. Things like, is this a valid user account? Do they have a verified email? That can get pushed back to the server. And that's the traditional, the server backend says, hey, I'm always consistent on this, and here's what that data looks like. The data also, the server also facilitates real-time sync by sending push notifications and using SignalR to keep the devices in sync as fast as possible, even when they're not near each other. And last, one of my favorite features that we added to this is that the two or more devices should be able to sync even if the server was down or there was no internet connection. And the original driver for that was a typical developer ridiculous edge case. What if we're on a plane going to Australia and we're on an 18-hour flight and our baby is sick? How do we give them medicine? And it was great because when I'd explain that to people, they'd laugh. Like, that doesn't happen. That's an edge case. You're just building this because you want to. And not long after our first beta of this was in use by my wife and I, we took a road trip with our newborn. Lo and behold, we were out somewhere where we did not have an internet connection. And so I said, okay, this has got to work. We've got to make disconnected sync work. And that was a fun challenge, combined with the fact that the devices have to be authoritative. All of that led to event sourcing. And this was my first real foray into building a complete system using event sourcing. And it's been a fun adventure. So let's just jump into a little bit of the architecture of the mobile app. So we've got view models. Everybody, I think, that does a Xamarin or anything similar on mobile uses a view model driven paradigm. And what we decided to do once the event sourcing evolved out of the app is use Mediator. That's the Mediator without an O from Jimmy Bogard, if anybody's curious which one. I liked it just because it was lightweight. And that Mediator pipeline ended up feeling an awful lot like a bus, like a end service bus or Azure service bus, but on device. And from that came my favorite design pattern, which is the distributed system. You have commands saying to perform an action, and as a result, an event or multiple events is published, and other things handle those events to implement business logic. Business logic in this case really means what do we do as a result of, for example, a dose being given. And so there's a handful of event handlers that update what I called an index. And an index is really just a snapshot. You take the events that fed into it and create a built for the view model of what that represented. So for example, we have a children index, which is just the list of children and what their next dose is and whether or not they have an allergy and anything that shows up on the main screen. And then we have a medications index, and that shows just the medications, and you can query by a specific child and get that details. And so there's all these different snapshots or indexes. And originally they were just basic object graphs, and the view models were reaching into them to get what they needed and display it. But as the distributed system, it's tough because it feels like a distributed system on the phone, which is fun to write, grew, I found that more and more things were changing in the index that the view models didn't realize had happened. That led me to reactive.net. And so the indexes became observable collections. From that, the view models can take a subscription on that data so they know whenever it changes. That change, I think, was the greatest light bulb moment as I got into reactive and understood how you could use it and saw how easily it fit into an application like this. It saved me a ton of pain. It got rid of probably 10,000 lines of horrible code listening for events in a view model. And if you ever think that your view model should subscribe to events from a mediator bus, don't. It shouldn't, ever. And so these handlers update the indexes, and then there's other handlers that update application services. So for example, on an iPhone, you can long press on the app and get shortcuts that say, like, you know, give Sam insulin, take a Tylenol now. And there's these little shortcuts. And so other handlers listen for appropriate events and update those shortcuts, or they update reminders that are local notifications. And then these indexes get persisted to disk so that I don't have to rebuild from the entire event graph every time we reload the app. Although the list of events is actually really quite small on the device because we trim them. We only keep the last 2 days worth of events on device, and the rest are accessible from the server anytime that the app needs them. If the user says, hey, show me how I've been taking this medication for the last 2 weeks, we can go fetch that. But we don't keep it locally because we don't want to have a whole bunch of data in memory. And then let's talk about the fun, the back end, what led me to RavenDB. In the very beginning, the idea of the app was solid. What we wanted, we knew all of the features, well, we thought we knew all the features that we wanted, but the shape of the data kept changing. Even as I was just doing like rough sketches on a piece of paper and showing people, hey, would you use this? Does this make sense? In my head, the shape of the data was constantly changing. And I really hate schema migration. I'm blown away that it's 2021 and it is not a completely solved problem. The tools that are out there are okay, but they still suck. And it's still painful. And so I said, hey, you know, I always go back to Raven, and maybe there's a reason. Maybe I shouldn't try something different because I know Raven, I know how it works, and I can trust it. And so I went back to Raven. And that was really great because you had just come out with, when I started this, 4.0 was new. And event sourcing was, or not, I'm sorry, the data subscriptions was an evolving, beautiful feature. And that ended up paying off in spades later on in the app. And then I also found that Raven fit event sourcing really well. As thankfully you have helped me find better ways to store that data in Raven, but it works out really nice because I can say, hey, I want to store all of my events. And so I have a collection of events and they're polymorphic. And they could be a tiny little event that's just a medication ID and a timestamp, or it could be a big chunk of data that involves, I took a blood pressure and I took a glucose reading, anything. And so all of that just works, which was really nice. And then came data subscriptions, which made Raven start behaving like a bus. And in case you can't tell, I really like message buses. I'm actually kind of sad MSMQ is going to go away. I thought that was such a great message store. And so using Raven to act like an event store allowed me to separate some logic from the primary API and move it into a background process. I think that allowed a really neat pattern to evolve, because I was using Mediator in the client app with handlers that deal with events, and I was using Mediator up in the API to figure out what to do when an event came in. And then I could use the same pattern in the background process. And something really neat that came out of that is that I could switch where I wanted a handler to run simply by changing a registration. So for example, while the app was in development, things like push messaging and SignalR notifications and figuring out what the hydrated model, the index or snapshot up in the API would look like, all happened in the same transaction where a user was posting data, and it was terribly slow because the push networking services, we're waiting on that, we're waiting on SignalR, all kinds of stuff. By using the Mediator pipeline in both the API and the background process, I started sharing all of my services and handlers in a shared library between these two projects. And so I could develop something synchronously, putting it directly in the API, attaching the debugger to just the API, and knowing exactly what is going to happen, and be able to step through it with a debugger, work through the inevitable problems, and solve them. And once I felt confident in that new implementation, I simply removed its registration from the container in the API, and then I switched over to the background project and registered that handler in the background. And then the Raven data subscriptions would automatically, when new events came in, it would just publish them on the background bus, and the same handler and the same service code could run. But now it was eventually consistent on a business level, and that worked out really nice.
Interesting question here. What happens if, so I'm thinking about the structure that you have, and a common problem in this domain is, okay, what happens if I messed up? I didn't check the app and I gave a double dose, or I checked the app, but there has been connectivity and my wife didn't update or something like that. And at a later time, we realized that, oh, both me and my wife gave insulin to the baby. So we have two events, and both devices are authoritative on the topic. So is it now something that both devices would push to the server, and now you can have a subscription that would validate and say, oh, there is overdose on insulin, or you missed the due date for giving the medication?
Oh, that's an interesting idea. So for double doses, you could absolutely have a handler in the server side that noticed two events for the same medication from different sources close in time, or rather it would validate that they broke the rule, because the back end has the same rules and implementation of validating the rules for how often to give a dose that the main application does. So you could absolutely have the server say, hey, it looks like you might have given a double dose of this, and push a separate notification to the device that says, look out, I think you guys might have both given this medication at different times. And the neat part is you could put the same logic on the device as well, so that even if they finally did sync disconnected from the server, the device would have sufficient information to do the same thing, because the server doesn't really have more information than the device about medications. It has the exact same information as all of the devices involved in a household. And so on the mobile app, you could definitely show a warning that said, hey, you gave Sammy insulin at 12:04 p.m. and your wife recorded insulin at 12:10 p.m. And that's really close together. You should check on the baby and confirm if this really happened. They might need medical attention, right? You could put that kind of a warning in there. what has most happened, we actually haven't had that in anybody that's tested it. So it's an interesting thing to think about. What we've had most often is that we're disconnected and we didn't run the app close enough in time for the app to synchronize with each other, and we'll get into how they sync. And what happens is I record a dose at 12:01 of Tylenol, and my wife sees me give the baby Tylenol. And then a couple minutes later, she opens the app and Tylenol isn't in there. Usually because the server was down because I kept developing and I kept breaking things. And she says, "Oh, the Tylenol's not in there." Well, he definitely gave her Tylenol. I saw him do it. And she hits the button
she
for
recorded
Tylenol.
that.
Yep, we both recorded. I recorded it when I did it, but she just didn't get to see it. And then she saw me do it and she records it also. And then when it synchronizes, it will show, hey, there were 2 doses of Tylenol. And what that's led to is her saying, "Hey, you broke it again. I didn't see it. Why didn't you put the Tylenol in there?" I went, "Oh, I put the Tylenol in." And then we both open up our phones and suddenly they sync, and you will see a record at 12:01 and 12:04. It says Ryan gave Tylenol at 12:01, Kim gave Tylenol at 12:04. And we go, "Oh, huh. Okay, yep, I broke sync again." And you delete one of those doses and move on. But I really like the idea of having the app actually say, "Hey, this looks like something you might want to look at." And the event model allows that because the devices and the server has all of that data. So let's look real quick at what I did the first time on the server side. And like David said in the intro, I've been using Raven for 10 years. I absolutely love Raven. I love the strict boundary between eventually consistent and ACID. I love knowing that if I'm going to go get something by an ID, or I'm going to save something, I can be rest assured that has actually happened and I'm not getting old data. If I query an index, I know that that could be old. It's very rare that it happens, but it does. So when I first started building this, I thought, okay, I'm just going to use indexes. I'm going indexes all the way, baby. And let's just save the events to Raven and let indexes generate the different pieces of data that I needed, the different pseudo documents. So for example, I needed to know what the latest data by device was, which is events by change vector here in yellow. And I needed to know what doses each child had been given by day. And that's down below in yellow. And that worked great until on rare occasions, it didn't. It was usually because I had done something on the server. I had failed to exit a loop when I needed to, and so the server was spinning at 100% CPU. So the indexes just didn't have time to catch up. Another time it was when I had a simulated load test. I had a couple hundred devices mocked out and hitting the server. And what happened was occasionally somebody trying to get data would get stale data from the index because they're eventually consistent. That's the guarantee that they give. Well, that doesn't work when you're talking about, did I give a medication dose, right? Like it's just bad. Eventual consistency is great for things like what's your score on the game or what's your ranking, things like that. Or even like who all is in my household and show me their names, right? That's not critical data that has to be up to the nanosecond. And so despite knowing where these boundaries were, it still bit me because I thought, hey, I don't have to worry about it. So version 2 of the server, instead of using indexes to get me those extra pieces of documents that I needed, I promoted them to real documents. So in an event save transaction, the server saves 3 documents. Well, really, it saves 2 and does an insert in 1. So we save an event document, right? Straight to the events, that's it. Boom, it's done. Then we go check the child device vectors, which keeps track of our latest change for a given child on a given device. And say, okay, let's update that. And last but not least, we insert it into the child doses document. And I say insert here because this is a patch operation intentionally because that document can get big. And in the beginning, I was just loading the document and adding the event into a array, and that worked fine. And then when we had a test where we did a couple hundred doses simulated on a single, yep, then that document got to be a couple hundred kilobytes. And Raven still performs great when there's 10 users doing that. But I looked at that and I said, why do I need to load that whole document? I don't care what else is in it. And so then I went and said, okay, let's go see how to do this with a patch. And that took all of 5 minutes, and boom. Now all I'm doing is sticking that into the event into that doses by day document. And that doses by day document is part of what helps keep the request traffic down, because it's for any given UTC day, you can go look up all of the doses, those dose events for a child, and pull them down. And that lets the client say, hey, I want to go look at this specific date range. Give me all of the doses for this child between August 1st and August 15th, 2020. And it's trivial for the server to go get that.
You just mentioned UTC dates, and I went into what happened when you move date zones, time zones, and stuff like that, and I just cringed so hard. I still have painful memories from trying to resolve those things in an appropriate fashion. And that's just crazy.
It's beyond painful. The decision I made on this app was every single date is going to be a UTC date. And then when we display it to the user, we'll format it for their local time zone. And that solved the main pain of dates, which is, hey, how do I know when this really happened? What was the moment in time that this actually occurred at? Versus what does the user's current location represent that time as? And so by storing everything as a UTC date and then formatting only when we're displaying, it deals with people crossing time zones. I gave a dose of a medication when I left Los Angeles, and now I check the app when I get to Sydney, Australia, and it shows it in local time at the correct moment that it happened when you left, the 18 hours ago or whatever the duration of that flight is.
Yeah, what I'm thinking about, okay, after I'm done with an 18-hour flight, I'm not up to doing a math on time zones and wait, how long was that? I don't know. And it's funny because we're talking about, sum and addition of small numbers, and like my mind go blank at that. Yeah.
It is absolutely not fun to do date math. Even when you're not hired, I'm not fond of doing date math. That was part of what drove me to that. I started to look at Noda time, and then I was like, okay, so now how am I going to serialize that? Okay, now I have to write an extension for Raven to be able to do the math. And I went, no, I'm going down a rabbit hole. Let's just use date time UTC, and we're good. And so it gets injected into every service. There's a nice way to test it, and I know that I am consistently using it all the way across the project. So let's talk about the really fun part, syncing. Specifically syncing when there's no server connection. So I left the server out here. Both devices have Wi-Fi or Bluetooth or something that works. And actually, as an aside, I went down a rabbit hole of what happens if the device doesn't have Wi-Fi or Bluetooth? How can I sync with it? And I tried 2 different other implementations. I made an ultrasonic sync. If you ever think you want to do that, you don't. It works.
How would that work?
So the device encodes the data that it has to transmit into frequencies that the phone speaker is capable of producing, but that are at the edge of human hearing. And on the other end, a microphone is listening and converts that back. It's basically a modem over the air. And it can work. And it can even work in a noisy environment, which is really neat. I simulated an airplane by having both of my children scream at the top of their lungs while I had music playing. The former is much easier to do than you'd think. You just take a toy away. Or take a toy from one and give it to the other and then switch. And then they're both screaming. And it was neat because it worked. it was just limited to about 100 bytes a second.
Okay.
That wasn't very useful. So that was okay. I learned a lesson. I tried something. I said, okay. And if you're interested, there's actually an open source library somebody made. He made a very robust ultrasonic communication channel. And he uses it for things like synchronizing phones to flash in a stadium during a sporting event. It's neat. I'll share the link at the end if anybody's interested. And ultrasonic didn't work. So then I said, okay, what if I have the devices show each other through the screen and the camera some information that allows them to sync? So think like a moving barcode.
Animated QR?
Yep. I really wanted the code that Apple uses for pairing an Apple Watch with an iPhone. If you've ever seen that, it's this really beautiful, it looks like moths circling around something or something. It's just dots, colored dots, but it creates a pattern that it can use to transfer a fair amount of data. Well, Apple doesn't share that code. And I started to go down the path of re-implementing it. And thankfully, my wife used to be a pretty good project manager. And she walked by my laptop one day and she said, "What in the world are you doing?" I said, "Well, I'm making a synchronization mechanism that uses animated data on the screen." And she gave me that look. So yeah, you know what? I'm going to go back to making normal sync work, and I'm just going to stop playing with this. I'll put that in a branch. I'll put that in a branch over here, and we'll look at it one day in the future. And she said, yeah, one day in the far future. So let's look at how synchronization actually works over Wi-Fi or Bluetooth. And now on iPhone, anybody who's familiar with it, this uses the multipath connectivity. So Apple makes figuring out how to communicate over a local wireless channel really easy. Android, unfortunately, doesn't. I have a primitive, pure Bluetooth implementation of this. But at this time, the private beta of the app is all iPhone, so I didn't worry about people who were on Android. I said, okay, let's just make this work well on one platform, and then I'll make it work good enough on more. So the apps advertise, and crucially, both apps have to be running. The app can't be in the background. You can't be doing something else. You can't even have a share sheet or anything up. The app has to be foreground for it to have access to Bluetooth through this means. So you're both in the same house. You're within, say, 60 feet of each other. The two apps are going to identify each other, recognize that they are there to share data, and they're going to start an exchange. And the first thing they're going to do is share a secret in a secure manner. It's kind of a Diffie-Hellman exchange with each other in order to say, hey, what kids do you know about? So in this example, the advertiser phone knows about blue, green, and red. And the browser phone knows about blue, red, and purple. So think about blended households or a babysitter, where not everybody knows about the same children on their devices. And so we didn't want to share any events that you shouldn't know about. You shouldn't know about, you know, the kid I babysat down the street. You should only know about your kids. And so this exchange lets the two devices figure out what data they are allowed to share with each other. Once they've done that, they go through and they confirm, hey, you know this pre-shared key, you know this key. Okay, cool. We both know about blue and red. Now we can synchronize because we know what children we're allowed to talk to each other about. So the synchronization looks daunting. It's actually really simple. And the part that really cracked me up is after I had implemented it, I had built the change vector concept, I had built out how the synchronization worked. I'd actually started talking to Oren about porting RavenDB to the iPhone. And he said, hey, go look at our source code and tell me what it would take to port it. And so I went and I looked and I said, hey, I wonder how he implemented distributed synchronization between nodes in a cluster. And it's a vector clock, which is the same thing I stumbled on. And it's a very similar synchronization of, hey, what do you know about? Do you have this? His is much more robust. It's got some features I didn't need on a mobile device, but it was nice to say, okay, look, I stumbled on this thing called a vector clock, and it turns out it's probably a good idea. That was reassuring when I was working with this data. So A and B want to synchronize. And the way that synchronization happens is one party starts it off and says, here are the latest change vectors I know about for my events. And so in this example, client A says, I know about child 1 on device A, clock 5. I know about child 1 on device B, clock 7, etc. Now, just to be clear, these are only the most recent vector that this device has seen for each child and other device. We're not sending the entire list of vectors that it knows about, only the most recent clocks. So we send that over to client B, and now client B takes the list of vectors and says, okay, what do I have that you already know about? I'm gonna filter down to the list of what you don't know about. So in this example, client A already has child 1 B7. So we're gonna get rid of that. And now I know what events on B client A has not seen. And now we just send those events across. And when that's done, client A got along with that from B the list of what B's latest known change vectors were, and it just repeats the process. And it turns around and says, okay, thank you, B, for those events. Here are the events you didn't know about. And when that's done, both devices have the same events for the children that they are allowed to talk about. Now, in an example like this, B might have events from another child and A might have events from another child. But if they don't share those children, the events do not cross between devices. One thing that's neat that does happen is that if a device talks to a third party, so let's say myself and my wife and the babysitter, and my wife has her app open when she gets home and talks to the babysitter, and she gets an event from the babysitter's device. In this case, child 1, device C, vector clock 1. So she had that information from the babysitter. When I came home, I didn't have it, but at the end of the sync, I got it. And that was a really neat feature to get out of this synchronization because it's a real life scenario that can happen. We get home and I'm worried about the kids and my wife wants to just pay the babysitter and get her out of the house. But they happen to both have their phones open so she can pay her. And so they both synchronize, and then that later syncs with me. And while this is an example of how the local sync works without a server, all of this synchronization implementation is shared. It's the exact same code, and we swap what the communication channel is between HTTP or Bluetooth or that ill-fated attempt at ultrasonic, or one day my flickering light, possibly seizure-inducing synchronization approach. And they'll all use the exact same sync code because it has about 1,000 unit tests covering every scenario we could think of and everything that we've ever seen break it. And I really don't want to write another version of that synchronization algorithm, not if I can avoid it.
It's complex. It's really complex.
Yeah, it is a really hard problem to solve. When we started building this app, we couldn't believe nobody had done this. We thought, this is so simple. Why hasn't anybody done this? And it took me about a year to get synchronization solid. And at the end of that time, I went, oh, I know why nobody's done this. Absolutely makes sense. This is painful. It's worth it, and it's really neat to see it in action. But it is definitely not the trivial app that we thought. Mm-hmm. Now let's see. We've got a couple of technical details. So I've talked about these IDs throughout this, and an ID. Well, here I've represented it as like a device ID is a letter A or a B. You can think of that like in Raven, how it has tags for synchronizing between nodes in a cluster. The actual ID in Raven is a big number. I think it's a GUID, right? Yeah. This uses, this is a fun library I found, NULID. You can find it on GitHub. Somebody came up with this really neat idea called a lexicographically sortable unique ID. And so it's a 128-bit number that inside of it has crunched the full value of a date time now, right? All of those ticks fit in there. And then it has a random number tacked on the end. But the random number generator that they have, actually have a couple different implementations you can swap, but all of them have the same behavior, which is that every request for a random number within the same tick will give you an incrementing number, monotonically increasing. Is that the term? I know you had a GUID implementation that would give you an always increasing GUID once upon a time, I think back in Raven 2, Raven 3.
Yeah.
It's the same concept with a random number. It's always increasing. So the result is, even if you generate 1 million of these unique IDs in one tick, which you can, I can't imagine any scenario where that happens, but you can do it, they will always sort correctly in order. That's awesome for an event store. It also lets me say, hey, from that ID, I want to know what time this happened at. And because it's a specific type, it's this implementation of NULID that says, hey, I know how to parse out my value into a date time and a random component. I can at any point in time say, tell me what time this happened at. And that is extremely important for debugging. If I want to know, hey, is this event the one that I think it is? For example, when I'm debugging date time problems, which thankfully I don't have to do anymore. And then within this, a change vector just becomes a device ID and then that vector. And then in this case, vector is one of those words that seems scary. It really just means a number. It's an int. And it increases every time you use it. So when the device, there's a service on the device that says, give me a new vector. And that always increases it, and it keeps track of what the last value was. So that the event store can say, what's the order of these events based on the device and the vector on that device. So we can always order things by how they happened on a physical device. And we don't have to depend on date time to be correct because of clock skew or people messing with their clock or anything. The date time is helpful, but what really matters is that vector. That vector wins when you're figuring out what order events happened in. And last, I just wanted to point out a really awesome project called Poly. If anybody's not familiar with it, it's actually used heavily in the .NET framework. For example, their Azure Service Bus library uses it extensively. And Poly made it trivial to do HTTP not fun stuff. Dealing with connectivity failing sporadically, dealing with retries, backoffs. Hey, I got a 401, I need to go authenticate and then retry this operation. All of that stuff, Poly wraps up all of that logic in an easy to test manner. I wish I had discovered it at the beginning of the project because I attempted to implement something on my own, and you don't want to do that. Like it's a big problem space to deal with everything that can happen in an HTTP connection. And let's see, some lessons I learned in this. Throw away your MVP. My mistake was I didn't. I built an MVP. I built it quick and dirty. I actually followed a pattern called just freaking hard code it that somebody I know used to advocate quite a bit. And that works really great for an MVP. The problem was when I validated the idea and people said, hey, I like this, I want this, I want to use this. I said, okay, I can just keep throwing the architecture I want onto this. I can bolt it on, I can refactor, and you can't. Like it's, especially in a mobile app. This was done in Xamarin Forms, which is an interesting, different problem. I should have put something up here about Xamarin Forms because it is the worst way to solve a cross-platform mobile app, except all of the other ways. I have a love-hate relationship with Xamarin. I love being able to write my code in C#. I hate playing what will this work on the device, because that's what you're playing. It's a Russian roulette for mobile development. But I should have thrown away the MVP. I should have thrown away probably the version that followed it. And I should not have been afraid to get rid of code. I even put that in here twice, right? Throw away your MVP at the top and at the bottom. Don't hesitate to throw away non-MVP. Sunk cost fallacy is a real problem in software development. Anybody who writes code feels that way. I wrote 15,000 lines of code. I don't want to throw this away. This can work. I can make this work. It's usually not worth it. Oh yes, and then if you know a domain in your project is going to require consistency, don't try to use an eventually consistent approach. Just don't. It doesn't matter if it's cleaner. It doesn't matter if it's less code. Even if it's easier to reason about. If it's something that absolutely requires a consistency guarantee, don't mess with it. That was the mistake I made in version 1 of the server. And then finally, I think most people probably know this, build something you're passionate about. Don't build something because you think the market wants it. And I think Oren will absolutely attest to that, because this man loves what he built. RavenDB is awesome. And it shows because he cares, right? Like, he loves it. So he keeps adding useful features. And the same thing happens when you build your own thing. If you build something that solves a problem for you, it's going to be good. And there's going to be other people who want it, almost guaranteed. And most importantly, you'll care about keeping it supported. I've built other apps where I thought, hey, the market wants this, and my heart wasn't in it. And I ended up spending, 6 months, 8 months building something and going, I don't want to sell this. Like, this is just work. This isn't fun anymore. And so that's the big lessons I learned in this project. And that's it. I think we had a few questions, but unfortunately, the presentation mode in my computer doesn't let me see what they were. I apologize.
And give me a second. I will find them. We had
while you're finding that, I might as well.
Yeah.
So this is the last slide, and I was actually debating whether or not to put it in. So this is the why. Why I cared about this app is that my first kid was born 6 weeks early. My best friend's kid was born a couple months early. And so I got a preview of it from him, and I had no idea what I was in for. 3 weeks in the NICU is not fun, but they really ingrained in us a checklist. And at the bottom here, you have a snapshot of what our checklist looked like at one point. And this is what babysitters and grandparents would be expected to do before I had the mobile app. And they'd look at this and go, I don't know what I'm supposed to do, right? This was on paper, and it was on a checkboard, on a clipboard, and they had a pen attached on a string and everything. And this was how we made sure we didn't make mistakes before we built the app. And it works, but it doesn't scale beyond the people who build it, because my wife and I were the ones working on it all the time. And so we knew what each abbreviation meant. We knew how we wanted to use it, and it became daunting for anybody else. And so that was what led us to build this. When we finally got a little bit of sleep, my wife said, hey, it would be great if there was an electronic version of this checklist. And I said, yeah. But she said, I think I know somebody who can write an app. Oh, well, yeah, let's do it. And Tended was born.
Here we have questions from Matthew Luck, I think. Syncing data when connectivity is unavailable. And I think you already answered that. In addition to the ultrasonic system, there is something called TXQR, which is animated QR codes. And apparently there is a GoSample implementation. And they have this is a one unidirectional mode. So this is not like TCP where you have stream to both sides, but you have one mode, and the capacity is between 1 to 9 kilobytes per second. So I'm not sure.
Oh, that's usable.
Yeah.
That's absolutely usable. TXQR.
Yes.
Okay, I'm definitely going to take a look at that. And if my wife catches me, I'm absolutely going to say, hey, Oren pointed me to this. Right?
We also have a question from David Bergman. Can you explain where you store the vector events on the mobile in case when the device is offline? What happens if the mobile app captures an event and then the battery dies, for example? When you reopen the app, what has happened with the event?
Absolutely. So that problem is actually what led me to looking to port Raven to mobile, which if you're looking for a task of pushing a boulder up a hill, that one might be it. Mobile is just not a good fit, unfortunately. The Raven code is fantastic. It's clean, but it's made for a multi-user HTTP connected system. There's probably a chance I will not give up on trying to make a version of Raven work on mobile, but it's going to be an extremely light version. What I built for this app was the beginning of that path. So the application stores events when they happen, no matter what, whether it has an internet connection or not. In fact, it actually writes the event to disk before it even publishes it for anything else on the application to work with. So each event gets serialized to JSON and written to a separate file in a structure that looks very similar to how the documents are stored in Raven up on the server, just to aid in debugging, so that I can go in and say, show me what events were on this device on this day for this child. When I'm debugging, I can go look at that. So we persist it to disk right away, and then we publish it. And the very first thing that happens when we publish it is we attempt to sync with the server if we have an internet connection. And if we don't, oh well, we'll try and share that with the server later. And then we go ahead and we publish it on the mediator bus, and the local handlers take care of it and update the snapshot and call into business services and all of that. So to answer the question, if you record an event and then your battery dies, the moment you hit yes to giving an event, because there is a confirmation on every event, on every dose, I want to give this child Tylenol, and it will say, are you sure you want to give Maddie Tylenol right now? Yes. As soon as you hit yes, that data has been written to disk. So if it crashes, when you plug it in, the data is still there and it will pick up and resume. And there's even logic that checks, I don't know if it's going to make it onto the production build because this doesn't happen often, but there's logic that checks on startup to see if there are any events written that did not get written to an index for exactly this kind of scenario, or for crashes, because when you're in development, code crashes.
Okay.
Let's see. Oh, somebody asked about the security of Raven. So it didn't really affect this app because I'm not directly writing to Raven. I'm talking to an API that talks to Raven. So Raven gets hidden from the device. But the way Raven is built, it is technically publicly available unless you go to a lot of effort to hide it. And there's no reason to, because the certificate security that Raven uses is fantastic. You get when you set up a cluster, you get a client certificate, and you add that to whatever devices you want to have access the Raven web UI. And you get an application certificate, which you give to your app code. And that's the only way you can talk to Raven, is over HTTPS with a client certificate, which I love because now I don't have to worry about security on the database.
We have, I think, one final question from Pierre Mengal. I hope I'm pronouncing that properly. The recommended implementation for data acquisition mobile app getting data 10 times per second and sync with online viewer.
Yes, that is a challenging problem. I'm going to point you at Polly again, because it will make that a lot easier on you to deal with retries and what happens if the first two succeed but the third one fails. It's helpful for that kind of stuff, for the overall HTTP connection. In this app, the way that I dealt with that problem, where I need to be able to possibly send a large amount of data quickly when the app comes back onto a network with a connection to the server, is that whole synchronization process. First, I say, here's what I know about, and the server says, yep, I need this data, and I'm going to give you back this data you haven't seen. And that whole operation, actually sending the events to the server, can be done in a batch. I chose to do it one at a time, so that I could have strict controls over, hey, we're not ever going to risk saving an event if the previous event failed. Because I was concerned about if I sent multiple batches, it would be possible for the server to start processing the second batch before the first, or for something middle of the first to fail, and then it gets the second batch. And you don't trust the network is what I can say about that. Be paranoid.
Yeah. In general, Pierre, if you have a high volume of ingest data, you have to take into account in the mobile a few scenarios. One of them is that you may not be able to access the internet. And in many cases, even if you have access to the internet, the latency and bandwidth that you may have may not be up to the task of keeping up with the rate of change. In many cases, it might be better to say, okay, I'm going to take the data, record it locally, and in some cases, I might want to do some processing, compression, or something like that, and then put it on a queue to be sent to the server. And the idea here is that one of the most costly thing that you can do in an application is to go over the network. And if it takes you 2 seconds to send something over the network, it tends to matter little if you're sending 1 kilobyte or 7 kilobytes. But if you want to send 1 kilobyte but if you want to send a megabyte or 1,000 times 1 megabyte, sending a kilobyte will almost always be much faster because you have just one round trip to go. So the proper recommendation would be, okay, let's try to aggregate the information, send them once every second, once every 5 seconds, or something like that. But the problem in this case that you also have to take into account what happens if I don't have internet connectivity. Maybe, again, I'm on a flight for 18 hours and I'm having 10 times a second some event. At the end of the day, I'm going to have to face with tens of thousands or about 100,000 items that I have to send. And if I'm going to try to send all of them in a single batch, it's actually very likely that I would fail somewhere in the middle. So you want to actually, in order to build something more robust, you want to have batches and compression of that, but also limit the batch size to something more meaningful. And in many cases, that's something that you have to do with your application. Poly can help you with a resending of the request, but setting the batch size, deciding what the data format should be, that's on the application itself.
Yeah, and it's something I think most people find that they will have to keep resolving. You'll find a solution, you'll use it, and then your app evolves a little, and you go, okay, so gotta change that again.
Yeah, that's how it works.
Yeah, tests, and more tests.
Okay. Ryan, thank you very much for coming to this webinar and sharing your experience with us. It was very interesting. And thanks.
Thank you for having me. It's been fun to talk about it. This is the first time I've talked about the technical aspects of the app to anybody other than my cat or my children.
Yeah, there is the the debugging technique, talk to the duck. Apparently,
yes.
talking to my baby son is very useful in that regard, both helpful for me and from my perspective. The moment that I start talking to him about technical stuff, he immediately falls asleep. I presume out of self-defense. So that's a victory for everyone.
Yeah. How old is your son?
Right now, 9 months.
Oh, fun times. Enjoy it.
Yes, I'm waiting to the point where he can sleep the whole night. I'm going to enjoy that very much.
Yeah, my daughter is 4 years old now, and I'm still waiting for that.
Okay. Yeah.
All right. Well, thank you very much,
Okay.
and
Thank you.
have a good day.
You too. Okay. Goodbye, everyone. Thank you for showing up.